Hello everyone. I hope you all are doing very well. In the series of evaluation metrics, today we are going to discuss about R squared metric. Basically, it is a kind of regression metric when we are having something which is related to a regression technique, or we are working on the model which is regression model. Then for evaluation of that model, we may prefer R squared metric. So basically, R squared is a statistical measure that quantifies the proportion of variance in the dependent variable that is predictable from the independent variable, right? So basically, it is useful metrics to assess the goodness of fit of a regression model, right? So let's begin with it. At the final, if we are going to get R squared value as 1, then we can say that the model is perfectly predict the target variable and it is an ideal condition. And if the R squared value is 0, it means that model does not explain any variability in the target variable beyond the mean of the target variable. And if it is closer to 1, means it is moderately okay. If it is closer to 0, means not that much acceptable, right? So basically, we can consider a simple linear regression problem where we want to predict a target variable y based on predictor variable x, right? So what is our problem setup? Suppose we have a data set consisting of pairs of x and y values, that is x1 y1, x2 y2 till xn yn, right? So our goal is to fit linear regression model of the form y equal to beta naught plus beta 1 x, where beta naught and beta 1 are the intercept and slope coefficient of estimated from the data, right? Now, steps to calculate R squared, we only need to follow these steps, nothing else. So while doing so, we can achieve our goal. So fit the linear regression model. So first we need to fit the linear regression model to our data to obtain estimates for beta naught and beta 1, and the model will predict yi cap, that is predicted y value for each xi, as yi cap equal to beta naught cap plus beta 1 cap xi. That is our linear regression model. Thereafter, we need to calculate the mean of all y values. That is, whatever we are having y values, we need to calculate average of them. After that, we will calculate total sum of square, that is TSS in step number 3. That is total sum of square, which is going to measure total variance of the observed y around the mean value, right? That is total variance of the observed value around whatever mean value we are going to get from here, right? And there in this way we are going to able to calculate TSS, that is total sum of squares. Now step 4 is, after calculating TSS, we are going to calculate RSS, that is residual sum of squares. So we need to compute residual sum of squares, which measures the variance of predicted y around mean y. So RSS, that is residual sum of square, is measurement of variance around predicted variable, whereas TSS, that is total sum of square, is measurement of variance around observed value, right? So there, in that way, we are going to calculate RSS, that is total residual sum of squares, with the help of the linear model equation. And thereafter, we finally calculate computed R squared with the formula that R square equal to 1 minus RSS, that is residual sum squares, divided by total sum of squares, right? Now, if R square value is now, if R square value is 1, it means that it is perfectly ideal condition where model is predicting in ideal condition. Each and everything is okay, 100% accuracy, you can say like that. And if R square value is 0, means it is not predicting the things, but it is only giving the values around the mean value, right? Okay. Now, let's come to the problem, numerical problem. With the help of that, you can get the R squared matrix very much clearly. So suppose we have the following data, 1 comma 3, 2 comma 5, 3 comma 7, 4 comma 9 and 5 comma 11. That is x1 y1 and x2 y2 till xn yn, that is n, value of n here is 5 because we are having 5 data points, right? Now we need to fit the linear regression model, that is y equal to beta naught plus beta 1 x, to predict y from x, right? So by performing linear regression, we can estimate the beta naught, that is intercept, and beta 1, that is slope values. Now, step 2 is we need to calculate the mean value of all y parameters, that is 3 plus 5 plus 7 plus 9 plus 11 divide by 5. That is, we are going to get 7. The average value of this y vertices is 7. Now, we need to calculate total sum of square, that is observed value minus predicted value. So, yi, that is our actual value, you can say here, that is 3, right, minus yi, that is mean value, 3 minus 7 and its whole square, plus the second value is 5, that is y2 minus mean value, that is 7 ka whole square, plus y3, that is 7 minus mean value 7 ka whole square, plus y4, that is 9 minus mean value, that is 7 ka whole square, plus y5, that is 11 minus mean value, that is 7 ka whole square, right? Now if you are going to calculate this, 3 minus 7 ka whole square 4 square, plus 5 minus 7 2 ka whole square, plus 7 minus 7 0 whole square, plus 9 minus 7 2 square, plus 4 square again. So ultimately the value we are going to get is 32. The value that we are going to get here is 32. That 3 minus 7, that is 4 ka square, is 16, plus 5 minus 7, right? Okay, so 3 minus 7, that is minus 4 ka whole square, that is 16, plus 5 minus 7 2 ka whole square, that is 4, plus 0, plus 9 minus 7 2 ka whole square, that is 4, plus 11 minus 7 4 ka whole square, again 16. So the value we are going to get is 16 plus 4 20 plus 20, that is value is 40. The value we are getting is 40. It is total sum of square value. Now after that, we need to calculate a residual square of sum, and in order to calculate residual square of sum, we also need the mean value of x as well as y. So mean value of x, you know, all the x vertices we are going to add 1 plus 2 plus 3 plus 4 plus 5 divide by 5. We are going to get 3, and y mean is 7, right? So we are going to calculate slope first, that is beta 1 cap. That is nothing but the formula is given, xi minus x bar, that is the observed value minus predicted mean value, into yi minus y bar, that is observed value, or the vertices given minus mean value, and we need to divide it with respect to x, that is xi minus x bar ka whole square. So this is the x1 minus mean of all x vertices into y1 minus mean of all y vertices. This is x2 minus mean of all x values. Thereafter y2 minus mean of all y2. Similarly, x3 mean of x, y3 mean of y, x4 mean of x, y4 mean of y, and so on. And we are dividing similarly with xi minus x bar ka whole square, that is x1 1 minus mean of x is 3 ka whole square. Similarly x2 2 minus mean of x, that is 3 square, and so on. So final result we are going to get here is a 2. So beta 1 we are going to get 2. Now similarly we need to calculate intercept as well, that is beta naught. Now beta naught is intercept, and the equation is y, that is mean, minus beta 1 x bar. So you know what is the mean value of y, that is 7. This 7 minus beta 1 already calculated, that is 2, into mean value of x, all x vertices mean value is 3. So ultimately intercept we are getting is 1. So beta naught, that is intercept, is 1 and the slope value is 2. Now what we need to do, we need to follow the linear equation. There you know that y cap equal to beta naught plus beta 1 into x. So by following this condition, we will put the value of x vertices. So x vertices are like 1, 2, 3, 4, 5. So what we need to do, we only need to substitute value of x here in order to get this value. So we are substituting beta naught equal to 1 as we have calculated. We are going to substitute beta 1 equal to 2. Already we have calculated. And into linear regression model, that is this equation, and we are going to get predicted yi, predicted value. So you can see here, the predicted value for y1 is 1, that is beta naught, plus 2 into x1, that is 1, that is 3. Similarly, predicted value for y2 is 5, for 3 is 7, then 9, and then 11. This is our predicted value, that is yi cap. This is predicted value, which we have calculated using linear regression model equation, this. After that, we are going to calculate residuals. That is the difference between observed value and predicted value. So the difference between observed value, that is for y1 3 minus predicted is also 3, right? Here also for x2 5 minus 5. For x3 7 minus 7, x4 9 minus 9, x5 11 minus 11, that is 0. So here 0, 0, 0, 0, 0. So residuals we are getting 0. It means that the difference between predicted value and observed value we are getting 0. So if we are getting predicted value and observed value difference 0, it means that it is ideal condition. Means model exactly predicted the value, that is the actual values, right? So finally, the residual sum of square formula is, we need to just add all these errors that we get here. We are going to add all these residuals. So we need to add the squares of all these residuals, that is also 0. So we have already discussed that if residual sum of squares for this linear regression model is data is 0 now. The residual sum square is 0 now. We have calculated like that, right? So the formula of r squared is 1 minus RSS, that is residual sum of square divided by total sum of square. That is 1 minus 0 divided by, so ultimately the value we are going to get is 1. So r squared value we got 1. So we have already seen that if this is the condition, then if r squared is 1 means model is perfectly predicting the target variable. And yes, it is so, because whatever exactly value we were having, model is also predicted. That is why we got residuals 0, right? So residual sum of squares here is 0, which itself indicates that there is no error. Means it is ideal case where the linear regression model is perfectly fit the data, due to data is being perfectly linear. So the RSS is 0, that is residual sum of squares are 0, indicating that there is no variability left unexplained by the model. So this is R squared matrix. I hope the concept is clear. You can follow us on the social media link. All the links are mentioned in the description section. And for further such kind of sessions, do subscribe, like, and stay tuned. A very nice day, guys. Jai Hind, Jai Bharat.